Let us now talk about Newton's laws of motion and start with the first law. Now the first law talks about two cases only, remember. One is the case of a body at rest and the other is a case of body in uniform motion. And it says that if a body is at rest, it continues to do so forever. Likewise, it says that if a body is in uniform motion, which don't forget is an ideal case, then the body will continue to do so forever. Unless, of course, some external force acts which makes the body behave in a different way. So if we have a body at rest, like this eraser, then if we do not disturb this eraser, that is, if we do not apply any force on this eraser, then this eraser will continue to remain at rest forever. Now I cannot show you the case of uniform motion here, as I've already told you, uniform motion is an ideal case. But you need to trust Newton with this statement here, that is, if a body is in uniform motion, it continues to be in uniform motion forever, remember, unless of course compelled by an external force. Because if we did not have dissipative forces, then when I would give a slight push to this eraser would have never stopped. In fact, it would have continued to move with the same speed in a straight line if there were no dissipative forces. But because of dissipative forces, what happens is when I give a slight push to this eraser, it stops. It stops. So therefore, remember, in our world, uniform motion is not possible. But what Newton is saying about this ideal case here is 100% true. So these are the two things that Newton's first law of motion speaks about. So if a body is at rest, it forever continues to be at rest. And if a body is in uniform motion, it forever continues to be in uniform motion unless some external force acts to make it behave in a different way. Since this first law also talks about inertia, because if a body is at rest, it continues to be at rest. If a body is in motion, it continues to be in motion. That's a case of inertia. So therefore, the first law of motion is also called the law of inertia. Now the second law is more of a mathematical statement. It says that the rate of change of momentum is directly proportional to the applied force and it takes place in the direction in which the force acts. It meaning the rate of change of momentum. Say for example, a force F acts on a body for time delta t, because of which the velocity of the body changes from v1 to v2, or because of which the momentum of the body changes from p1 to p2. Therefore, the change in momentum denoted by delta p is equal to p2 minus p1, and the rate of change of momentum therefore is delta p upon delta t. The change in momentum divided by the time in which this change in momentum takes place. Therefore, from the second law of motion we get the force is directly proportional to the rate of change of momentum. This is what the second law of motion tells us. Now the proportionality sign can always be replaced by an equal to sign provided we add some constant. So k is the constant of proportionality here. So therefore F is equal to k into delta p by delta t, or F is equal to k m into delta v by delta t. Since there is no change in the mass m of the body due to the application of force F, so therefore m is a constant. Hence it comes out of the delta sign here. Therefore F is equal to k m into a, where a is the acceleration, equal to delta v upon delta t, that is the rate of change of velocity. Hence F is equal to k m into a. Now we've defined our unit force in such a way that when it acts on a body of mass unity, it produces an acceleration of unity. That is, when m is 1, a is 1, then F is equal to 1. So if all of these three things are 1, unity, then k has to be unity. Because of which we get F is equal to m into a. So this is the equation that we get from Newton's second law of motion. And we can see from this statement that whenever there's a force acting on a body of mass m, what happens is it produces an acceleration. So this is what we get to learn from Newton's second law of motion. The easiest of all the laws now, which is the third law of motion. It says that to every action there is always an equal and opposite reaction. That is, it tells us that forces always act in pairs. So if you have a force which you call the action, then there has to be another force acting which will be its reaction. So remember, forces always act in pairs. This is what the third law of motion tells us. If at any point we see a force acting such that it has no reaction, then that kind of a force is what is called a pseudo force, remember. Pseudo meaning not real. All real forces, according to third law of motion, remember, act in pairs. One thing I forgot to tell you is that action and reaction, they always act in opposite directions, and they also act on different bodies. For example, say you're very angry one fine day and you decide to give one blow to the wall, to a concrete wall. So what happens is, you giving one blow to the wall is the action, and your action is acting on the wall. But the wall is going to hit you back. So the wall hitting you back is the reaction. And where does that reaction act? The reaction acts on your hand. So action and reaction, mind you, they act on different bodies. And I suggest you to give a look at all of the examples of